So here we're going to look at something called Leibniz rule for differentiation. And what it's really helpful for is when you want to take the nth derivative of a function, it breaks it down and makes it a lot easier to get the result. So this one here, for example, e to the 4x cos x, if I break that down into the functions f and g, I'll let f equal e to the 4x. So that's the function of f. And cos of x, I'll let that be g. Then what I need to do here, to take the derivative of that, I've got f prime g plus f g prime. And then for the second derivative, I've then got to take the derivative of that, which will give me another product rule, and then that one. And the result of that, so on and so on, I'm going to end up with a whole tree of results of differentiation. Whereas Leibniz rule breaks it down and it makes it a lot easier. So if I've got, for example, f times g to the nth derivative, as we've got here, so using this example, my result for Leibniz differentiation rule is I've got k equals 0 to n. I have the binomial coefficient n choose k, and then I have my function f, and I take the n minus kth derivative, and my function g, obviously using binomials, we go from g to k. So that's what we've got there for our result. So this is the result we're going to use in this question. Okay, now n choose k. Now here, our result here, or sorry, our question here, we've got the fifth derivative of this function here. So we've worked out what f is and what g is. So this is f of x, this is g of x, and here I've got n equals 5. So n equals 5. Okay, so now let's work out what our binomial coefficients are. So we do these bits one at a time. So let's work out this bit first. So we've got, let's do it here, n choose k. So that sends me to n is 5, and I go from 0 to 5. So 5, 0, I need 5, 1, 5, choose 2, 5, choose 3, 5, choose 4, and 5, choose 5. So they're all the values that I need. Now 5, choose 0, that's always 1. 5, choose 1. Well, we can use Pascal's triangle if you're not too sure on how to calculate all of these. So Pascal's triangle, let's just draw it up. Start off with that situation. So I've got 1, add the numbers in the middle, 1, add the numbers in the middle, 1, add the numbers in the middle, and for the fifth row, add the numbers in the middle. And my binomial coefficients will be along this line here. So I've got my 0, 1, 2, 3, 4, 5. So 5 choose whatever number is in here, that's my result. So 5 choose 0, I've got the 1. 5 choose 1, I've got 5. 5 choose 2 is 10. 5 choose 3 is also 10. 5 choose 4 is 5. And 5 choose 5 is 1. So that's the result of my binomial coefficients. So let's take this off the board. Now let's work out the derivatives. Okay, so I want n minus k derivatives. So k goes from 0 to n. So basically this goes down from 5 down to 0. Now the 0th derivative, that's not a derivative, that's just the function itself. So a little proviso here, 0th derivative of f or g, that's just the function itself. So that's e to the 4x, and that's cos of x. Okay, so now what we need is the first 5 derivatives of these functions. So let's work those out. So a little colon in between each. So the first derivative of e to the 4x, that equals 4e to the 4x. Second derivative, see as this is just a constant, these are going to be quite easy to work out. So second derivative is 4 times 4 is 16. So that's 16e to the 4x. As it's the exponential, the input never changes. Third derivative, 16 times 4 is 64. Fourth derivative, that's 64 times 4 is 256. And the fifth derivative is 1024e to the 4x. So that's reasonable for us to work out that. Now cosh of x, now it's not quite the same as the standard cosine. This just stays positive and you go from cosh to sine. So the first derivative is sinh of x. Second derivative is back to cosh of x. And it just fluctuates backwards and forwards all the way. Sinh of x, fourth derivative is back to cosh of x, and fifth final, we've got sinh of x. So that's all our derivatives. So now we need to work out the sum of this. So we've got this component, this component, this component already here on our chart. So now what we want is from k equals 0 to 5. So if k equals 0, what have we got? Well, we've got n choose 0, so that's 1. So we've got 1 times the fifth derivative of f and the function itself of g. So fifth derivative of 5 is 1024e to 4x times the function itself, which is cosh of x. So that takes care of that. So when k is 1, when k is 1, 5 choose 1, we've got 5 as our coefficient. And then this time we've got the fourth derivative and the first derivative. So now we've got 256e to the 4x times sinh of x. So that's when k is 1. And then what we do is at the end of this, we just add them all up as it's a summation, and that will give us our result. So k equals 2. So now we've got the third derivative, which is 64e to the 4x, and 5 choose 2, which is 10. So 10 times 64e to the 4x times cosh of x. K equals 3. 5 choose 3, which is 10. Second derivative is 16e to the 4x times sinh of x. These are pretty easy because he's just going to alternate. K equals 4. I want the first derivative, which is 4e to the 4x, and 5 choose 4, which is 5. 5 times 4e to the 4x times cosh of x. And then k is 5. I want the function itself and 5 choose 5, so that's 1 times e to the 4x times sinh of x. Okay, so that's the result of all the elements of the summation. That's the result of all my differentiation. So now what I need to do is just add them all together. So I can stick that into this part here. So first of all, they've all got e to the 4x involved. So I've got e to the 4x. So that's involved in there. So I can factor that out. Now adding all of these together, I'm now going to have a number times cosh or a number times sinh. So now what I want is add up all my cosh coefficients. So I've got 1024. Let's write this down here. So 1024 plus, got a cosh one here, 64 times 10, so that's 640, and 4 times 5, which is 20. So add those up, 1024, 1664, 1684. So 1684 cosh of x. So that's factoring out inside here. And then we add onto that sum of all the sinches. So I've got 5 times 256. So that's going to give me 256, 512, 1024, 1280. So here I've got 1280. And here I've got 10 times 16, which is 160. And here I've got 1 times 1. So let's just add 1. So now add that up, we've got 1, 4, carry 1, 4, and 1. So 1,441 for that one. 1441 sinh of x. And that is the result. That's the result of my differentiation. So the fifth derivative of this is this. So that's the result of that. And that takes care of that question. Okay.